All right. I think I just had a pretty cool idea for something I can add to the Onyx compiler, and I just want to get it documented so I don't forget any of the details that are in my head right now. So someone was asking in the Onyx Discord about compiler extensions and a way to be able to extend the functionality of the compiler through some kind of library or whatever it is, right? I'm not entirely sure what they're thinking of doing, but some way to extend the functionality of the compiler to define some kind of new syntax or something, right? And so there are other languages that do this, right? Like the Rust compiler, for example. They don't necessarily have extensions to the compiler, excuse me, as much as they just have procedural macros, right? So like in Rust, I don't know the exact syntax, but you can basically have a function that takes Rust code and turns it, it takes any code and turns it into Rust code that will work. And the way that they do that is through these like macros. So like there's a lot of things in the Rust ecosystem that have like some kind of view layer. And so view is the name of the macro. The exclamation mark is necessary to define the macro. And then in these curly braces, you can put literally anything. And it's the job of this procedural macro to parse the stuff in here and translate it into Rust code, right? And so, this view macro could be HTML. It could be another custom language. It could be Rust code itself, but something that's going to be translated in some capacity, right? And so if I could have something that is like this, that would be really, really cool. So I was kind of thinking about how I could make something like this work for Onyx, because the problem with Onyx is that it does not have any type of compile time execution in the way that Rust has its procedural macros or Zig has its comp time or anything like that. And while that is something I could add, I'm thinking about the details of it, and I know it's a little complicated, and it's a little complicated to get right. So I was thinking, what if instead, let me make this window a little bit bigger. What if instead, all of these macros that you might have are, I don't know what term Onyx would use for them, but these types of things, what if they were handled by a separate process? So here's the idea. When you're compiling, there would be a list of compiler extensions that could either be applied at like compile time, like you could Onyx run extension HTML view, and then you run your source file, which could contain something like this, and we'll talk about what that actually means. Or there could be like a pound compiler extension flag that you specify HTML view, and then that enables this for this compilation, right? And then it kind of does it in a delayed way. So my thoughts are, this would be parsed, right? Any symbol followed by an exclamation mark, and then some curly braces would be made special to the compiler. So the tricky part is with the lexer, I would have to, it could be this, or maybe I'd have to do something a little bit grosser like this, that it's very clear that this is not normal Onyx code, because these double array brackets could never appear in any kind of Onyx code. And then maybe you wouldn't even need an exclamation mark, because you can just say it like this. Whatever the syntax would be, it'd be something special that the lexer would basically just consume this wholeheartedly. It would not try to parse it into any individual pieces. It basically would treat it like a string, right? But I want to avoid having triple quoted strings, because then you lose any syntax highlighting that you could have between these brackets. So maybe it looks like this. Maybe there's a curly. Maybe it's double curly. I don't know. The problem with curly is that it's hard to know at the lexer level when it's the stuff between curlies is a block or not. I could have a thing of, if it's a exclamation mark, maybe some white space, and then a curly, maybe that means it, whatever it is. Syntax we could debate, but the idea is the stuff in here would not be touched at all by the compiler. It would basically just be a string. The important one would be the symbol before it, which is the, I don't want to call macro, but the extension that it's going to invoke. Okay, so the way I'm thinking that these extensions would work is that they would be little Onyx programs. So they would be pre-compiled into WebAssembly, and they would use the Onyx runtime like API. They really could use like WASI as their API, but it'll be easier and more self-contained if they use Onyx's, because then I can just run Onyx run. And so the idea is that these will live somewhere, maybe in the compiler toolchain, or maybe, somewhere in some way, like a library could provide its own compiler extension, right? That's a much more useful thing, is like per package you install, it'll have its own compiler extension. And so what that looks like and how you ship these WASM files, I don't know exactly, but somehow you're going to specify that. And then effectively, I'm going to run that program. And what that program is basically going to have is, over standard input and output, it's going to have a little API. So the API might look something like, right, so you'll have the compiler, and you'll have the server. So the compiler might say something like, okay, so I'm explaining this poorly. Every one of these compiler extensions would be started as a subprocess and would just hang around. The compiler will communicate with them through standard input and output. So the compiler could say something like, do you support the view macro? And again, I don't know if I'd call these macros, but do you support this macro? And maybe the extension does, maybe it doesn't, but the extension would say something like, yes, I do, right? And then the compiler would say something like, expand this macro, right? Expand this view macro, where it gives it the raw quoted stuff between these brackets. So it wouldn't be the brackets themselves, obviously. It would just be the stuff inside of it, probably just verbatim, all spaces, tabs, everything included, right? The compiler would ask it to expand this view macro. At this point, I'm guessing what I will do is the compiler will wait for messages from the view macro, or from this sub process, right? In the simplest case, the extension will simply respond to something like, here is the expansion, right? And this will end communication with the extension. It will just wholeheartedly say, here's your expansion. And then from this point, we'll talk about what the compiler will do, but my thinking is that it will just replace this entire view part with whatever code the extension expands to. So this will respond with actual just Onyx code that will then be fed through the parser. It'll probably have to be a little bit more specific, because it depends on whether or not this is like a top level macro and whatnot. So there's details to be figured out. But it'll expand to Onyx code that'll get reparsed into syntax tree nodes and then reinserted. So, right, this could become just like a function call, right? This could be a React style thing where this is going to now just become like an element of H1 with no children, or however this gets encoded, right? But it'll become some new Onyx code that will then be reparsed and put back into the syntax tree, right? But there could be something more complicated that the extension has to do, right? It maybe has to query some extra information about the surrounding context, like, does this symbol exist? Is this thing defined? Right? There's probably some more API that you have to have around it. And basically the extension would then just ask the questions, right? So instead of saying immediately, here's the expansion, and ending communication, like, here's the final request, it can make other requests to the compiler that the compiler has to answer, saying, is a symbol defined in the scope? What is the type of this symbol? Or just, what is the type of this expression, right? Something like that, where it can kind of converse with the compiler and do some stuff dynamically. Always ending with, here is the expansion. It could also do something a little bit fancier, because obviously here's the expansion is what is going to get put here in this macro expansion. And again, I don't know if I want to call these macros, but for lack of a better word, that's what I'm calling them for now. So in this macro expansion, we're going to put this code, but you could say, here is some other code I want you to run and put in like the current file, basically. Put it in the current file scope. And so maybe this view macro would become something like, view whatever jargon, and then so it just becomes a function call that function call, right? If I do this function would contain all of the logic for converting this HTML or whatever it is, right? Whatever that looks like, that's what this function would take care of. So that's kind of the idea, is that whenever you define these extensions, they are just processes that get spawned by the compiler that interact over standard input and output, like very simple API. I don't know what that looks like yet, but it'll be a simple API that'll have an Onyx library to help you. And the idea is then you just compile this down to a WebAssembly binary. So then the compiler will just run that subprocess, communicate standard input output, and then when the compiler encounters one of these macros or just expansion things, it will ask each extension, like, do you support this kind of expansion? If it does, it asks it to expand it, and they figure out what that expansion should look like. Now, of course, this is incredibly powerful. Like, while it's maybe not quite as powerful as like procedural macros in Rust, this would give Onyx a whole leg up in a lot of different things, right? You could have these HTML macros. We could have like a wit bind gen kind of thing where we just say something that looks like this, and then we can put in, I don't even know the syntax for the WebAssembly interface types stuff, but we could just put that in here, and then all the extension does is parse that and turn it into definitions that Onyx can use. Or does the opposite, where it creates the extra stuff, right? I mean, there's a whole bunch of stuff that you could really do here, right? Of course, you have to be a little clever. Like, you have to, in this case, you have to write an HTML parser, right? Because, you know, if you want to be able to say like, oh, the ID is node ID or whatever, where node ID is like some kind of string, you know, you have to be able to define what that looks like. And this logic is up to the view extension, right? Which, you know, is my problem. I need to think about as the compiler developer, but it's also not. That can be something pushed on to the end user that they just have to have control over, right? And so, you know, this could be expanded into something that looks like, you know, I don't know exactly, but this is maybe a property list, and then it just becomes something that looks like that. I don't know, just kind of spitballing, but I think you kind of get the idea that, like, just by having these little extensions that are just processes that the compiler communicates with, we can have these hooks that you use to expand arbitrary things of code. And so this could be really fun, because you could have whole sub languages inside of Onyx, like domain specific languages that just get translated into Onyx code, right? There would be something interesting here about what if you want to have Onyx code in these view macros? I say view macros, just in these expansions. Like, what if you want Onyx code in there? Is there a way to like access an Onyx parser to make that easier? The answer right now is no, there is not, but it should be possible, right? And so this, I think, for like bang for your buck, this is a pretty easy-ish thing to implement, right? Because like this can all be done synchronously. We don't need like multi-threading or anything weird. It's just a simple standard in, standard out, just defining what that API looks like, and then making the interesting stuff with it. The only like weird compiler things are the whole, well, when you get this back, you have to like parse it and send it into the abstract syntax tree, which shouldn't be too hard at all, but it is something that you have to do. You know, there's things I'm thinking about with the API. There might be benefit in having like a wait for me kind of thing. Like, the extension can say, I cannot expand this macro yet. Tell me later. Like it tries to query some information, and if that information isn't available, it says, okay, try again later. And then the compiler has to, basically, it'll have to put that entity, which is all this is going to be, is just an entity expansion, put that entity back on the queue, and then it'll keep retrying it until the extension eventually gets the information that it wants, and it can actually expand it. So it's going to be a little tricky to implement, but I don't think it's going to be too bad. And I've seen the kind of code generation built into the language, things that you can do, and I think it'll be really powerful. Because as foreign as this is going to be, and as weird as it's going to be that you have to like write a separate program to interoperate with this, it's not much different than proc macros in Rust. Like, if we're being honest, proc macros are incredibly complicated, and so at that point, they're basically just separate programs that are operating on your Rust code. They just happen to feel like they're in the same code base. But in effect, they're basically just entirely separate things. And so little details like how does this WebAssembly file get to the person's computer, right? If they install the cool framework of the day and they want to use the expansion thing for it, how does that get into the compiler, right? If you do like compiler extension /HTML view.wasm, like I guess you could just put the WASM file in with the Onyx code, but maybe that's not a good idea. Whatever that's supposed to look like. But I think this is a relatively easy thing to get implemented, and it would bring a lot of power to Onyx. So this is what I just want to get documented, because I think there's a lot of potential here. So I'm excited to work on this. I'm going to try to get this typed up into a proposal and get it out to the Onyx Discord. I think the people there are going to have a lot of ideas for it. So I'm really excited about getting this feature out there. Anyway,